So let's see, I can't dive in and find a power series representation for this function, knowing what we know about a geometric series. So my mathematical responsibility is massage the left-hand side in such a way that it looks like that. So here I go. I'll replace every x on both sides with a negative x cubed over 2. Now, how about not doing something to both sides, but merely on the left-hand side, multiply top and bottom by 2? Now remember, I'm doing this in such a way that I'm remembering that I'm holding this true for only values of x that are less than 1 in absolute values. Now getting rid of this 2 by multiplying both sides by 1/2. And simultaneously multiply both sides by 3x squared. Would you mind if I took a brief moment to check my arithmetic? I said multiply both sides by 3/2 x squared. Squared looks good. 3/2 looks just fine. Now, in integrating left-hand side, think of me with this. But integrating the right-hand side term by term, just think of me this. And perhaps simplifying a tad bit. How about the following? Whoops, hold it, everybody. You know what, I just committed a mistake. So it looks like I knew that I needed to be myself room, but once I did it, I forgot that I need my constant integration. However, if you allow on both sides x to replace with 0, clearly c is just a natural log of 2. And so there's my first constant term. So here I go. Let me simplify what I have in expanded form on the right-hand side. But that can be this. That's a 16. My goodness. All right, everybody, I think I like it. So I do think I've answered my question, which is, what is a power series representation of this function? And there it is, at least in expanded form. But if I asked you for the power series representation for that function in summation notation, you might have been writing a summation representation of each of these power series along the way. But if you haven't, which I don't, just create it at the end. Now, the first term is not going to fit the pattern, so I'll keep it out of summation notation. And it starts at, well, that starts at, n really starts wherever you darn well please. If you start at 7 or negative 17, don't worry about it. I got an easy trick in my head to check if your answer matches mine, where I start my end. So don't even worry about where you start it. Do it at whatever is convenient to you. I like to start at n equals 0. All right, let's talk about this. When it comes to these terms, neglected the first one since I pulled it out. Notice how term by term I'm changing signs. So how about this? I'll have a -1 factor. I think raised n, but I'm not sure. It might be n plus 1. Let's check it. First term is going to be positive, but when I plug 0 for n is positive, I'll keep it. Otherwise, I change it to an n plus 1. Let's take a peek at the denominator. Look at these factors. 2 to 2 to 3, the first factors. 2 to 2 to 3 to 4, they increasing linearly? I think. I'm wrong. It didn't work with the first two. But notice, if I think of this denominator as 1 times 2, then notice how this first factor downstairs goes from 1 to 2 to 3 to 4. It's a linear progression, like a line, y equals mx plus b, where m is equal to 1, that's the slope. But of course, when n is equal to 0, I should get a 1, so I think that factor should be n plus 1, not just simply an n. Now look at the second factor, 2, 4, 8, 16. I should say, look at the second factor downstairs, 2, 4, 8, 16. Those are powers of 2. The first one is 2 to the raised first power, but that would be 0 plus 1, so the exponent should be n plus 1. Now, as far as a variable factor is concerned, I think that's merely x to some power, but here too, there's a linear progression from 3 to 6 to 9 to 12, just like a line whose slope is 3. So shouldn't it be a 3n plus something? Now to figure out something, do this. When n is equal to 0, the exponent should be 3. But when I plug 0 for n, the exponent is question mark. So I guess question mark should be 3. You can double check me, see if I made a mistake. When n is equal to 1, I get 6, but that's the exponent when n is equal to 1. If n is equal to 2, I get 9, but that is the exponent for that third term. So I not only have a power series representation for this function in expanded form, but also using summation notation. And I expect both those representations, but I'll be clear in asking for that.